In this video, we will perform DFT computation. Compute n point DFT of the following signals. X of n is equal to delta of n minus n naught. Take the first one, that is x of n is equal to delta of n minus n naught, where n naught is less than or equal to n but greater than or equal to 0. So before computation, let me explain what is delta n. Delta n is a delta function, or it is also known as impulse signal. It is defined as, that is, delta n value is 1 for n is equal to 0 and its value is 0 for n is not equal to 0. It means that it is defined only for n is equal to 0. That is, it will be something like this. This is delta n and here say n equal to 0. So its value is only for n equal to 0. For all other cases its value is 0. So therefore here for n equal to 0, it means delta of 0 is equal to 1. Now we'll see what is delta of n minus n naught. Delta of n minus n naught, it is defined as its value is 1 for n is equal to n naught and its value is 0 for n is not equal to n naught. So delta of n minus n naught is same as delta of n shifted by n naught units. It means that its value will be 1 when we consider n is equal to n naught. So in that case, if we take n equal to n naught in this equation, we'll get delta of n naught minus n naught, which is equal to delta of 0, and we know that delta of 0 is equal to 1. Now we'll come back to the problem. So we'll compute DFT of x of n. We know that DFT of any discrete sequence x of n is given by x of k is equal to summation n equal to 0 to n minus 1 x of n wn power nk. So here x of n value is given, that is delta of n minus n naught, which is equal to summation n equal to 0 to n minus 1. X of n is delta of n minus n naught wn power nk. So now I can expand this summation as x of k is equal to, I will substitute n equal to 0, that is delta of 0 minus n naught wn power, n value is 0 here, so it is 0, plus if I take n equal to 1, it will be delta of 1 minus n naught wn power k. Likewise, if we consider n is equal to n naught, in that case I can write it as delta of n naught minus n naught wn power n naught into k. So here, as I said, delta of n minus n naught value is n1 only for n is equal to n naught. So here we have taken n equal to n naught, so its value is 1. Rest all cases its value is 0. So it is 0 here, plus this is 0, plus we have the value of this one is 1 wn power n naught into k. So therefore I can write x of k is equal to wn power n naught into k, or I can write wn is nothing but e power minus j 2 pi by n into n naught into k. So this is the solution for this problem. I will consider the second example where x of n is equal to a of n. X of n is equal to a power n for n less than or equal to n minus 1 greater than or equal to 0. We know that DFT of any discrete sequence x of n is x of k. It is defined as summation n equal to 0 to n minus 1 x of n wn power nk. Simplifying this, n is equal to 0 to n minus 1, x of n is a power n wn power nk, or further I can represent this as summation n equal to 0 to n minus 1 a w n power k power n. I can represent this as in this way. But we know that summation n equal to 0 to n minus 1 alpha power n is equal to 1 minus alpha power capital N divided by 1 minus alpha. So therefore here we can see that this term is nothing but alpha power n. So therefore I can represent this as 1 minus alpha is nothing but this entire term a w n power k n divided by 1 minus alpha divided by 1 minus a w n power k. So this is the required solution. Thank you for watching.